Hi everyone, welcome to my channel, Math Made Easy with Terry in 10 minutes. So we're going to talk about parametric differentiation, okay? So it's important you watch the previous video. So in the previous one, I just introduced the concept, but this time I'm going to go in more detailed and I'm going to write maybe 7 steps. So the steps you need to solve any form of parametric differentiation, be it finding the angle or finding the equation of a tangent and the rest of it. All right, so before I proceed, don't forget to like, share, and subscribe. If you've not clicked the notification bell, I don't know what you're waiting for, please do so that when I post new videos, you'll be the first person to know. So as discussed in the previous video, like I said, there are 2 expressions for x and y will be described in the third variable, and this is called parametric equation. So for instance, if you have y is equal to 3t squared plus 5, okay? And you have x is equal to 4t cubed minus 3t. So you can see both y and x are described in terms of the third variable, okay? They're described in terms of what? T. Are you seeing it? So t here is going to be called a parameter. Is that right? So in some cases, you can have maybe y is equal to 3w squared, and you have x is equal to w plus 3. So you can see both y and x, all right? They are described in terms of what? A third parameter, w. Is that okay? So what then happens here is that to be consistent when I'm writing the rules or the steps, I'm going to just assume that the third parameter or the parameter is always t. Is that okay? I'm going to assume that the parameter is what? T. Is that all right? So, but I'm going to be using t in the steps, but it really means any parameter. It could be anything like w and the rest of it. All right. So I'm going to go straight and I'm going to start writing down the steps. So what I always advise students is that make sure when you are writing down the steps, please write it down in the paper, okay, or take a screenshot. Now in the next video, we'll be solving questions. So, but I'll be referring to the steps as we go along the way. Is that okay? So let's go. So we're going to talk about the 7 steps, okay, and how to do this, okay, how to solve questions that involve parametric differentiation. So number 1, the first thing you have to do is that you have to differentiate y in respect to t. So now you can see the third parameter here, right? Is t to give the y over the t. Okay. Then number 2, then after that, you then differentiate x in respect to t, okay, to give the x over the t. All right. Then number 3, when you're done with that, then you now divide the y over the t by the x over the t. So then you then divide the y over the t, okay? So the y over the t from step 1 by the x over the t from step 2. Okay? And this is going to give us the y over the x. Okay? And that is how you get the dy over the x. Okay? So it's dividing the y over the t by the x over the t. And after you do that, you then what? Simplify. Okay? Now, so in some questions, they might ask you to find the second derivative. Okay? They might ask you to find the second derivative. So that's the step 4. So if, for instance, we are told to get the second derivative, So the second derivative, so this is going to be the 2y over what? Dx squared, okay? So to get the second derivative, the first thing you have to do first is to differentiate, okay? dy over dx. So the dy over dx that you got from step 3 in respect to t. Okay? And this is going to give you, d dy over dx over dt. Is that okay? We're going to give you dy over dx over dt. All right? So number 2, the next thing is that you then divide the result from step 4i. Okay? By dx over dt. So dx over dt from step 2, okay? From step 2, okay? So now this is going to give you, will give you the second derivative we're looking for. It's going to give us the 2y over what? Dx squared, all right? And that is how you get the second derivative. It's going to give us the 2y divided by what? Dx squared. Then the third step, as usual, then you then what? Simplify. Okay? So that's how you get the second derivative, okay? So you first differentiate and respect to the t, then you then divide it by dx over dt, then to give you the second derivative, and you simplify. Now, in some cases, they could ask you also to find the equation of a tangent and normal. So that will be step 5, okay? So step 5 now, you could be asked to find equation of tangent and normal. All right? So the first thing you have to do is that you have to substitute the y value into the original equation to get t. So the first thing you do, you substitute the y value into original question or into the original equation. So into the original equation to get t. Okay. Number 2, after substituting that, you now substitute the value of t so this is from step 5i. Okay. Into dy over dx. So dy over dx from step 3 to get the gradient. Okay? So the gradient here is going to be called mt. Is that making sense? Then number 3, okay? So when you've done that, if you are looking for, if it's the equation of a tangent, Okay. So if, for instance, you ask to look for equation of a tangent, then you're going to use the formula y minus y1 is equal to mt x minus x1. So where the mt is the gradient or the slope of tangents. So you've gotten the mt from step 2 already. Is that making sense? Then, or in some cases, you can use the y is equal to mtx plus c, okay? So that is it, mtx plus c. Now, but in some cases, you could be asked to find equation of a normal. So if it's equation of a normal, you're looking out for. In this case, you're going to use y minus y1 is equal to mn x minus x1. So in this case, mn is equal to minus 1 over mt. So the mt you got from step 2 here is how you get the mt, mn. So mn is negative inverse of that. Some textbook usually write it as mn mt is equal to minus 1. So sometimes you could see it like this. It's exactly the same thing. All right. So where mn is the slope of the normal. Mn is the slope of the normal. While here, where mt is the slope of the tangent, okay? So mt is equal to slope of tangent. I've discussed this before, so that's the reason why I'm not talking a lot about it already. Right. So in some cases as well, you can also use y is equal to mn x plus c, but I always prefer to use the first one because they're way easier and they'll give me my answer straight up, okay? So that is it. So that's how you find the equation of tangent and normal. Is that okay? Now, in some questions, you could be asked to find the angle, all right? So find the angle from the horizontal. Number 6, sometimes you will be asked to find the angle from the horizontal. Okay. All right. So how do you find the angle? So for instance, if you had the dy over dx was equal to, let's say you had it to be a, so therefore the angle from the horizontal, theta. So when we talk about angle, okay, from the horizontal, we're referring to what? Theta, all right? So it's very important. So the theta is going to be equal to the tan inverse of a, and that will be the answer for that. So when you're asked to find the angle to the horizontal, it's going to be equal to the tan inverse of the dy over dx, the answer you had. Okay? And that's how you get that answer. All right, so let's go to number 7. So sometimes you could be asked to find the stationary point and the nature of stationary point. So those are another questions you could be asked to find. So you could be asked to determine the stationary point and the nature of stationary points. Okay, so some of the questions could be determine the stationary point, and nature of stationary points. Okay, so as usual, so the first thing you have to do, you have to first equate dy over dx to 0, basically to find the stationary point, right? So you have to equate dy over dx to 0, all right? And find for all possible values of t, okay? And find for all. So it's key, all, okay? All possible values. Of t. When you're done with that, the next thing is that you then substitute the values for t. We substitute the values for t. Okay, into the original equation. Now, the reason why you're substituting to the original equation is to find the corresponding y and x values, okay? So that you can find the corresponding y and x values. Okay? Then, when you're done with that, the next step, that's number 3. Okay? You then have to find the what? The second derivative. By differentiating the y dx and follow step 4. So I've talked about this in step 4. Okay, so you just go back, follow the same way to find the second derivative. Then when you've done with that, then you now have to now determine the nature by substituting the calculated t So by substituting the calculated t values, okay, from step 7 to II, okay, so from step 7 II, okay, to determine if the corresponding x and y coordinates are minimum or maximum. Okay, so if you solve it and you got the 2y over the x squared, you have it to be less than 0, so it means it's maximum. And if you solve this and you got the 2y over the x squared to be greater than 0, that means it's what? Minimum. Okay, and that is that for that as well. Okay, so that is it. So in the next videos, I'm gonna be going into each of these, and I'll start talking about how to solve questions for this. All right, so the next videos, I'm gonna start with how do we find the first and second derivative. So that means We're going to talk majorly, I think step 1 to step 4. Okay, so we'll talk about step 1 to step 4 in the next video. So I'm going to give questions that have to do with differentiating in respect to t, then getting the first derivative and getting the second derivative. So that's the next video we'll talk about. So please, for you to benefit from the next video, try as much as possible to take a screenshot, write this down, because I'm going to follow these steps when I'm going to solve questions. And so that's why it's important for you to subscribe and click notification bell so that when I post the next video, you'll be the first person to know. All right. So I'll see you soon. I'll see you in the next video.